Hi students, MCQ number 28. The electrostatic potential inside a charged spherical ball is given by the expression V equal to AR square plus B, where R is the radius of the sphere, A and B are constants. The charge density inside the ball has to be determined. Now, the expression for the potential is given as V equal to AR square plus B. Okay? If you differentiate this potential with respect to the distance R, that will give you the electric field. So, the first step is we have to determine the electric field. E is equal to minus of dV by dr. So this is the electric field on the surface of the charged spherical ball. So this is equal to d by dr is A into r square. If you differentiate, it will become 2ar. So this is 2ar plus 0. Okay. Therefore, because B is constant, when you differentiate, it will become 0. Therefore, electric field is equal to what? Minus 2A into R. So, this is our first step. Are you understanding this? Now, after this, the electric flux expression, flux phi is equal to integral E dot ds. E dot ds. Okay. So, this is equal to integral E into ds into cos of 0. So, this is equal to integral E into ds. So, inside this integral, instead of electric field, what we are going to write is minus 2AR into ds. So, this is now equal to minus 2AR taken out of the integral into integral of ds. Okay. Now, integral of ds, this is equal to the total surface area of a sphere, that is equal to 4 pi r square. Therefore, the flux phi is now equal to minus 2AR multiplied by 4 pi r square. So, flux phi is now equal to 2 into 4 is 8. So, this is minus 8 pi into A into r cube. So, 4 2s are 8 pi A r into r square is r cube. So, this is our second equation for the electric flux. Now, from Gauss law, this flux, okay, from Gauss law, this flux also is equal to what? Total charge enclosed divided by epsilon naught. Okay. So, this must be equal to minus 8 pi A r cube. We need the expression for Q. Therefore, Q is now equal to minus 8 pi epsilon naught A r cube. So, this is our equation number 3. Okay. But what is asked here, the charge density inside the ball has to be determined. So, what do you mean by charge density? Here is the charge per unit volume, is it not? So, finally, charge density, volume charge density. It is a volume charge density. Okay. So, volume charge density is equal to Q divided by V. V for volume, not potential. Okay. It is volume. So, this is now equal to Q is how much? Minus 8 pi epsilon naught A r cube divided by volume of a sphere. We have to substitute volume of a sphere. So that is 4 by 3 pi r cube. This is 4 by 3 pi r cube. Okay, some of the terms get cancelled. First r cube. Okay, so r cube and r cube get cancelled. Pi term also get cancelled. Then this 4 by 3 will come as 8 into 3. So we can use the symbol rho, okay, volume charge density. So I can take the symbol rho also, okay. So this volume charge density is now equal to minus 8 divided by 4 into 3 epsilon naught A. So this is epsilon naught A. Okay. Now this is 2 times 4 2s are 8. Therefore, the volume charge density is equal to minus of 3 2s are 6 epsilon naught A. So this is our final step. This is the answer. So the charge density inside the ball is found to be minus 6 epsilon naught A. So which is the right option? You see here option D, we are getting minus 6 A epsilon naught. Both are one and the same. Therefore option D is the correct answer. So such questions need practice. Okay. So we started with the expression for the potential. Then we differentiated this potential with respect to distance and got an expression for electric field. Okay. Then from electric field, how to find the electric flux. Okay. That is the second step. Then after that, the charge which is kept on the spherical shell Q we determined. Then we divided that charge by the volume of the sphere and got the volume charge density. Okay. I hope you must have understood this well. Fine.